So in our Algebra 1 book, we have the concept of sequences, and it comes up once every chapter. So instead of doing a chapter over sequences, our book chooses a topic from sequences every chapter. And so that's how I'll approach it. Now, those of you that were in our pre-algebra last year, if you remember, we did stuff with sequences, right? And so some of this will be review, and hopefully will strengthen your learning. If you've never had this before, then obviously some of this is going to be brand new to you. All right, well, what is a sequence? It's basically a set of numbers ordered in a distinguishable, what do you think? What word goes in the blank? Distinguishable pattern. Sequences, set of numbers ordered in a distinguishable pattern. Now, order, meaning the order matters. You just can't stick them in any order you want. They got to go in order. And so I have an example here of a sequence, 1, 4, 7, 11. What's the name of the dot, dot, dot? What are those called? 3 dots are called what? Ellipses. Let's go ahead and fill it in right here. Ellipses. E-L-I-P-S-E-S. What do 3 ellipses mean? They mean the pattern continues on forever. So this is an infinite sequence, right? Doesn't end to infinity and beyond. All right. Buzz is too old these days, huh? Buzz Lightyear. All right. But anyhow, infinite sequence. Are all sequences infinite? No, they could be. So if it's not infinite, what would it be? If it doesn't go on forever, it's got to be, anybody? Raise your hand. Luke? It is finite. It is finite. So it's either going to be infinite or it's going to be finite. All right, so infinite goes in here for B. An infinite sequence is one that continues on indefinitely. And the 3 ellipses tell you that. And let me pause for a second and remind you proper procedure. When can you use 3 ellipses? When you have at least 3 numbers in the correct pattern. So you can never have 2 numbers and 3 ellipses. You haven't had enough to establish the pattern. It's always 3 in the correct pattern before you use 3 ellipses. All right? It should be easy to remember. There's 3 dots, 3 of them. You need 3 numbers in the correct pattern before you use your 3 ellipses. All right, so 1, 4, 7, 11 is our example sequence. It goes on and on and on and on. All right, each number of a sequence is called a term. It's called a term. So I want you to focus back on our sequence right here. So the first term is 1, right? And the second term is 4. And the third term is 7. And the fourth term is... And the fifth term is 15. Because there's a distinguishable pattern, right? Say, but I don't see the fifth term. Well, yeah, but there's a 5th term and a 6th term and a 7th term and a 100th term and a 1,000,000th term, right? This thing goes on forever and ever. And so each number of the sequence is called a term. Each term is identified by a, all right, so here's a notation kind of thing, by a subscript. By a subscript. Okay, so stay with me. I want to show you a couple things. You don't need to draw this in your notes. I just want to focus your attention. So if you look back at this sequence here and look at the example sequence here, the one on the top has no braces, correct? Has no letter associated with it. We really don't know what sequence it is. It wasn't identified. On the bottom one, though, we called it sequence A. That's what the capital letter indicates. We have a name for it. It's always good to name a sequence if you're going to deal with more than one, because then we could say, all right, we're talking about sequence A. Your homework might do that. It might, in the beginning, before it gives you problems, it might say sequence A is this, sequence B is this, sequence C is this. So then you know which one it's talking about, okay? So the capital A is just an identifier of the sequence. So in this case, sequence A. Now, sequences can be shown without the braces or with the braces. And that's why the first one, it's more common to show them without the braces, and that's why in the first example I didn't put braces. But you could see them with the braces, and that's why I included the second time, so you understand it could go either way. Both are possible. Without the braces, with the braces. Now, sets, you don't have a choice. Sets always go in braces. Sequences, sometimes not, sometimes yes. Don't let the braces throw you off. Not a big deal. Okay, so we're talking about sequence A right here, right? That's what we're talking about. Now, notice that the A there on the left for the sequence is capital letter, and these A's are lowercase. When it's a lowercase letter, we're talking about the term. We're talking about the term. So lowercase a means I'm talking about a certain term from sequence A. If I had lowercase b, it means I'm talking about a term from sequence B. If I had lowercase g, I'm talking about a term from sequence G. So what do you think the subscripts tells you? So we got lowercase a subscript 2. So what does that mean? If you were to guess, what would that mean? Somebody raise your hand. You were to guess. Edward?
It's the second term.
Yeah, exactly right. The subscript tells you which term it is. All right, so what's the value of the second term? And that's pretty easy. It's a. So a sub 2 is 9. All this is the notation. We just want to make sure you know the notation. So a subscript 2, usually the wording is a sub 2. You kind of say sub instead of subscript because we shorten it. So a sub 2. It almost sounds like a of 2, but it's a sub 2. So a sub 3 has to be 15. And go ahead and fill in a sub 5. A sub 5. And class A sub 5 is 1, 2, 3, 4, 5, 27, right? Because each term in this sequence is 6 more than the previous. Do you agree? So you got to be able to look and see the pattern and then deal with the pattern. By the way, the first 2 examples are called arithmetic sequences. If you remember back to pre-algebra, there are also geometric sequences. We will talk about both in this course this year. Last year I only dealt with arithmetic sequences. I saved geometric for this year. But both of these are arithmetic. Right now we're just dealing with basics of sequences. So our next lesson, I believe in chapter 2, will deal specifically with arithmetic sequences. Okay, so obviously B, go ahead and fill those out. Pretty simplistic. We got sequence B labeled there. So I need B sub 1, B sub 3, and B sub 4. So this takes a rocket scientist. And the only debate is B sub 4, which class has to be what? -9, right? Because each term is 4 less, right? 3 plus -4 is a -1, -4 plus -4 is a -5, and -5 plus -4 is a -9. Piece of cake, right? No sweat. That should be easy. So remember, the subscript tells you which term you're talking about. The fact that this lowercase b said we're dealing with sequence B, and the previous lowercase a said we're dealing with sequence A. Okay, general term formulas allow you to find the value of any term, and that's very valuable. The general term formula allows you to find the value of any term. That's important. The general term formula is very, very valuable. And we're going to talk about a couple things As we get to arithmetic sequences and geometric sequences, we're going to talk about a recursive formula. I don't know if that rings a bell from last year. We did talk about it last year. We talk about an explicit formula. Now, the general term formula is the same as one of them, either the recursive or the explicit. Goes with one of them. Anybody remember which one? Recursive or explicit? General term formula? Anybody? You had a 50-50 chance. Actually goes with the explicit formula. Again, we'll talk more about that when we get to next chapter. But here's how you're going to use the general term formula. It's really easy. It's really, really, really easy. Because the variable here is the number of the term. It's probably not the best way to phrase that. It's a whole lot easier to show you what to do. So let me do this first example. Let me go a little higher for those of you. I see some of you straining here. If Windows will cooperate. Okay, so here's what I'm talking about. In this example, they want us to find the seventh term. So I want the subscript to be 7. I want a sub 7. I want the seventh term. So simply put, I'm going to substitute in 7 for the n, right? I did it with the subscript, and I'll do it in the formula part. I'm going to substitute in 7 for my n's. Pretty easy, right? Seventh term, n is 7. So now all we got to do is do a little bit of math to figure this thing out. So we all know 2 times 7 is 14. And we got a 14 minus 3. And so finish that up. The seventh term has a value of 11. Seventh term is 11. Okay. If they asked you the 100th term, the 100th term is what? Come on, say it if you know it. 100th term. 197, right? 200 minus 3. Right? 1,000th term. 1,997, right? Etc. No matter what term they ask you for, the general term formula will allow you to find it. So it makes things nice. All right, so go ahead and do B here. Find the 11th term. While you're doing it at your desk, I'm going to do it up here. Don't look unless you need to, all right? Don't look unless you need to. All right, did you get 36, 46, 46? All right, because all you're doing is subbing in 11 for your n. It's pretty easy. Okay, I chose C on purpose. By the way, C is a geometric sequence. Again, you wouldn't know that yet, and I don't expect you to know that yet. I'm just letting you know it's geometric. I know that because of the squared term. But remember, you need to be careful with squaring things or taking it to the fifth power. You got to be careful with your exponents and your parentheses. So if we do this one, right, my n is a 5. Technically on this is technically negative parentheses 5 and then squared. Now if you don't do it that way, you're going to get the wrong answer. How come I didn't include the negative in the parentheses that gets squared? How come I didn't do that? Anybody know? Because I got to tell you, if I do that, I get a different answer. Okay, let me pause for a second. Don't draw this. Don't write this. Some students will try to do that. I just want to show you that we get two different answers. So let's go ahead and finish this off. Don't do the right part. Just stay with the left here, this part I'm doing right now. So now I have a negative, and then I have 5 times 5 is 25. So that's a negative 25 and a negative 1. And what is the fifth term? The fifth term is a negative 26. Now, if I don't treat it correctly, negative 5 times negative 5 is a 25, and I get a final answer of 24. This one is wrong. And it all goes back to making sure that you apply the exponent only to its base. You might say, well, how do I know? Well, look, if it would have been the second one, the original would have looked like that. The original would have had a parenthesis around the negative n if it was the second one. So you'd know. So that, the way I drew it right now, is the second one, but that's not what we had, is it? What we had was no parentheses, therefore it's minus the n squared. Okay? So you got to be careful there. And why did I give that one so that you'd be careful there? All right, let's do D. Go ahead and do D and E. Be careful with E because the directions are different. Go ahead and do D and E. If you need help, look up the board, but hopefully you don't need it. Let's start recording this. All right, so we did R sub 1, we did R sub 2. Takes 3 things to establish a pattern. R sub 3, negative 9 plus 1. R sub 3 is a negative 8. Oh, now I see the pattern, right? And now I'm sure it's the pattern because I did 3 of them, right? 3 establishes the pattern. Do I need to do all the work on the last 2 if I know the pattern? Nope. R sub 4 has to be what class? Negative 11, and R sub 5 has to be class? Negative 14, and there's my first 5 terms. Now, when the homework asks you to figure out the first 5 terms, that's what your work should look like, right? If you know the pattern after the third, you can finish off. If you don't know the pattern after the third, then you have to keep use the 4 and use the 5, right? And let the math tell you. But if you can see the pattern a little quicker, you can finish it off with just the answers. Make sense? So we did 2 different things with the general term formula. We found a specific term. D, we found the 20th term to be 2. And we found the first 5 terms. So those are the things we'll want you to do with your homework tonight. Should be pretty simplistic. There's never a lot of homework to these sections. Today is Tuesday, though, and those of you that had me last year know that, therefore, tomorrow is a quiz. What's on the quiz? You guys that had me last year, tell them what's on the quiz. Pretty much everything we learned so far, right? I mean, it's just what I think the important stuff is from what we've learned so far. Hey, was it you guys that did the number sets? Was that this class? Did you do integers and rationals and irrationals? Did you do Venn diagrams? Was that you guys? All right. Hey, be ready for that stuff. What did we do last night? Midpoints and stuff. That was pretty easy stuff last night. And then today, some sequences. Those are the things you'll see on your quiz. Manana.